All right, guys. So welcome to week number 7. I mean, this is crazy. We're halfway through the semester, and I'm just going to finish today section 3.3. So as I mentioned, this is the final section that will be covered on your test. There is an online assignment or quiz that covers naming hydrates. I think there's one question. So we're going to learn or study how to name hydrates today. And there is a question in the chat here. Do the worksheets cover all the topics that will be in the test? And that is a yes. If every semester I get the question, what do we study? I would say a mixture of the class notes and the worksheets would be perfect. I wouldn't waste time studying your labs, but I would look at your course, videos, your course notes, and of course the worksheets. Many of the questions on your worksheets will be on your test. So it's definitely worthwhile going over your class notes and worksheets. One thing I'll mention, and then I'll actually get started here, is last night I uploaded all of the worksheets to chapter 3 with answers. So there are worksheets for you for chapters 1, 2, and 3 now, and all of them have the answer keys provided. Okay, so let's get started. Hydrates are actually pretty interesting. We haven't really talked about them, but you guys have seen them. You've probably seen them in your everyday life, but we've certainly seen them in lab number 5, last week. Hydrates are ionic compounds that trap water molecules in them. Literally, they absorb water. So if you remember lab 5, and again, I know I might not be everybody's lab instructor, but when you had to come up to the front desk and look at the solid ionic compounds, some of them looked quite wet. And what I mean by that is, I guess, yeah, they just looked wet or soggy or just not a pure, clean crystal like you would imagine something like table salt or sugar. If you can remember the lab last week, I want you to imagine the gray one or the purple one. When you looked at those ionic compounds, they looked like they were wet or slimy almost. And that's because many ionic compounds will absorb or trap water molecules from the atmosphere. This is how something that's called a desiccant works. So a desiccant, that's a weird word to say, a desiccant is a chemical that traps moisture. So people put them in their shoes or clothing or in food items to trap the moisture that forms. And ionic compounds are similar. Some ionic compounds, I should say. Ionic compounds that do not have water, we say anhydrous. Anhydrous, if you broke down the Greek or Latin in there, it would mean no water. So let me give you an example, and we're going to practice naming these today. This is copper 2 sulfate pentahydrate. I mean, what a crazy name. If you guys looked at this maybe a month or two ago, you'd think, oh man, I'd never be able to name something like this, but it's actually pretty simple. My metal ion is copper 2. Sulfate is from your polyatomic ion table. So this I get from my data book. Penta is a Greek prefix, which I'll talk about in a few minutes, which means 5. If you are familiar with geometry, I think that's the right part of math, the shape of a pentagon, that's a 5-sided object. So penta means 5 and hydrate means water. So I have copper, sulfate, pentahydrate. And the formula here is CuSO4. There's a dot in the middle. I'll explain that dot in a second, and then 5H2O. This means every CuSO4 formula unit is what we call them, but every Cu bonded to SO4 would have 5 water molecules trapped around it or inside it. Anhydrous copper 2 sulfate, which means no water, is just CuSO4, and it looks like this. It's the blue would be what we use in the lab. This would have water attached to it. The anhydrous would be here. So it's like the gray part that's been dehydrated or the water has been removed. Okay, again, don't worry about the picture. You don't need to know that. So how do we name hydrates? Well, you name the ionic part like a normal ionic compound. Take the cation and the anion and name them. I won't mention any names, but I had a couple of questions this weekend about the quiz. And a few students, I shouldn't say a lot, but a few students might be a little confused about the Roman numerals. The Roman numerals, these are only for metals with 2 or more charges. So like in this example, copper, if you look at your periodic table, copper can be +1 or +2. So in this example, the first thing I do is I name copper and I call it copper 2. And the reason I call it copper 2 is because I have 2 negative acetate ions. I'm going to show you all this with an example. So this is copper 2 acetate. And then I say mono, which means 1, and hydrate, which means water. So copper 2 acetate means I have copper bonded to 2 acetate molecules, then are surrounded by 1 water molecule. So I thought I had an example. Oh, I do. I have an example on the next slide, so I'll get there in a second. One thing that might be new to you, however, are these Greek prefixes. These are used in mathematics. They're used in chemistry. These are words that go before a name that represent a number. If any of you are chemical engineering students, you will see this a lot more in chemistry 3. If you are not chemical engineering, you will see this again in chemistry 2, just a little bit less. One thing I'll mention, for your test next week, you do not have to memorize these because you can use your notes. But I will warn you, depending on Corona or COVID, if we do your final exam in the school on campus, you will have to know these 10 prefixes. So for your test next week, you can use your notes. You can open this up. You don't need to memorize these. But a little warning, if we're on campus in December, when you write your final exam, you will have to know these. It is pretty simple. And I honestly, I don't like the idea of you guys having to memorize things, like pointless things. Sorry, you obviously have to memorize things, but something like this, the only reason I stress that you need to memorize this is because it's so important later on for naming molecules and organic compounds. So anyways, 1 means mono, 2 is di. Now, typically you would think bi for 2, like a bicycle and a tricycle, 2 wheels and 3 wheels, but the Greeks, they use di. 3, like a triangle, is 3-sided. 4 is tetra. 5 like a pentagon, which looks kind of like a house. That's penta, 5. 6 hexagon. This is a shape we use all the time in chemistry. That's a really bad hexagon, isn't it? I'm having the worst luck with this pen. There we go. There's a hexagon. Hepta is 7. Octagon, like an octopus or an octagon, if you watch like MMA or something, that's 8-sided. 9 is Nana, and 10 is Deca. You need to know these for your final and for future chemistry courses. I know it seems like annoying to memorize this, but you definitely need to know this for the future. Again, for the test next week, you can use your notes. Okay, so I'm going to give you an example here, and then I only have one more slide and we're finished. Okay, so how do we write the formula for a hydrate? First thing you do, write the ionic formula as normal. Just write, like in this example, just write barium hydroxide. Then you use a raised dot. It's not a decimal. I don't exactly know the purpose of this other than it really helps separate and show you that there's water attached to this ionic compound. And the last part, the third step, I guess here, is to write the number of water molecules followed by H2O. You use your Greek prefix, so in this case, it's 8, and I would follow it by H2O. So this is, again, it's pretty straightforward. Aman asks in the chest, why not, in the chat, sorry, why not plus? I don't I don't know. I think we would try, well, actually I can explain why we wouldn't use plus now that I think about it. Oops, sorry. I'm just trying to open up a white slide. That's a really good question, but it surprisingly has a good answer. If I had to, like, okay, this is a little bit going forward, but when you write a chemical reaction, okay, you write it like A plus B gives you C. So imagine if I had something like copper sulfate pentahydrate, and I was reacting it with like HCl, and I got some sort of chemical reaction happening. The reason I don't put a plus here, let me change my color, is this shows that they're completely separate, meaning they're not like part of one same compound. So I wouldn't want to use a plus here because in a chemical reaction, a plus symbol represents different chemicals, whereas this is a complete hydrate, meaning it's just the one chemical. Like when you open the bottle in the lab, that's what's in the bottle. So I don't use a plus because pluses indicate separate chemicals. All right, that is a good question. All right, so let's go back to this and name it piece by piece. All right, barium. Barium is Ba. Now, barium is in group 2, which means it has a 2+ charge, and only a 2+ charge. So no Roman numerals. Okay, Rn means Roman numerals, no Roman numerals here. Hydroxide is polyatomic. So I get this from my polyatomic ion book, in the data book, I mean. So I have my cation, I have my anion, and I know octa means 8 and hydrate means H2O. So now what I need to do is put all of this together. So I need 2 of these chemicals to balance out the, oh, sorry, let me say that again. I need 2 hydroxide anions to cancel the 2 positive on the barium. So I would write barium hydroxide. Again, the 2 means I have 2 hydroxides to cancel my positive charge on the barium. And then I would put a dot here, and then 8 H2O. Now, I mean, guys, on a test, if you forgot the dot or something, I personally don't care. I'm not crazy. I mean, you know, it matters, but I'm not going to take off many marks. But if you, I would strongly include putting the dot there, and the dot just represents that this is one molecule put together. Okay, so the finale. I'm going to do 2 of these, and then you guys are finished for today. And this is the end of the test 1. So after this slide, we're looking at section 3.4, not on test 1. Okay, so this is your cutoff. This would be slide 71. Okay, so let's do this. Write the name for the following. Well, okay, maybe what I'll do is I will do this one and this one, and then I'll get you guys to try them, and that's it for today. Okay, so cobalt chloride 6 means hexahydrate. I'm so close. I know that CO is cobalt. I know that Cl, it's definitely not in my polyatomic ion table. It's chloride. 6 means hexa. And then I write this as one word, hydrate. This is one word. Okay, I'm missing one thing. Okay, anybody in the chat, tell me, what am I missing in this name? What is missing from this name? For full marks, I'm missing something. Yeah, all right, cool. Abdullah, Aman, people in the chat, that's awesome. The answer I was looking for was just Roman numerals, but you guys actually told me what Roman numerals to put in. That's beautiful. Bader, thank you very much. Okay, the problem here is cobalt. Oops, sorry guys. Cobalt, if you look on your periodic table, can be 2+, or I think 3+. I don't have my table in front of me, but I think it's 2 or 3. So the people in the chat correctly said 2, and that makes sense because chlorine is 1-. So think about this. I have 2 chlorines. Each chlorine is -1. So my charge on my cation must be +2. Gotta be +2 to cancel out my -2. All right, perfect. So that's it. Cobalt 2 chloride, hexahydrate. You'll notice the name does not have a dot in it. Okay, I don't need a dot in the name. Now, if you did put a dot there, I don't care. Like, guys, I'm not a crazy person, but my name doesn't have a dot, only the formula. I'm getting interesting question in the chat there. The question is, what would be the name of Cl3? And that's a really interesting question because as a molecule, like all by itself, Cl3 isn't a thing. In nature, it exists as Cl2. But if you had something like FeCl3, it's still chloride. Even though that there's 3 of them, it's still chloride. We would call this iron 3 chloride because the charge on the iron would have to be 3+ to cancel the 3 negatives from the chlorine. So to answer your question, as a single molecule, there is no Cl3, but there is a Cl2, and we call that chlorine. But in a compound, if you had Cl3, we would call it like something chloride. We don't need to worry about the 3 doesn't change the name. We'll talk more. By the way, this thing on the bottom, this is in section 3.4. So we'll talk more about this in the next section. Okay, let me show you one more example, and then I'll get you guys to practice, and then we're done. My other class was only like 15 minutes. It's already 5 after 3, but anyway, it's okay. Okay, so sodium is 1 plus. There's no Roman numerals here because it's in group 1 charge. Carbonate is CO3 2 minus, and decahydrate would be 10. Deca means 10 waters. Now I do need to put these together. So what I would get, because this is 2 minus, I would need 2 sodiums stuck to my carbonate, and then I would put 10 H2O. There you go. There is sodium carbonate decahydrate. Again, I need 2 sodiums to balance out the -2 on my carbonate. If you're wondering, where the heck did I get carbonate? It's from your polyatomic chart, straight from the data book. Okay, I'm going to mute myself, and I would like for you guys to try the 2 that I haven't done, and I'll be back in maybe 2 minutes. So I would love for you guys to try these, and I'll be back in 2 minutes. Feel free to share your answers in the chat. Okay, guys, this is excellent. I'm again, in the chat, I'm getting amazing answers here. So let's go through. So I'll go quick because most people are getting the answers. This metal is magnesium, not manganese, but that's a very common mistake. I've done it myself. So magnesium. Now, I do not need Roman numerals because magnesium only has 1 charge, 2 plus. So this is just magnesium, no Roman numerals. Sulfate. For anybody in the class right now wondering, how did I know, or how did the other students know that it was sulfate? It's in your data booklet. Again, I cannot stress this enough. I have your data booklets outside my office, along with lab number 6. If you guys ever need a data booklet or lab 6, for example, go to my office. Anyways, so this is magnesium sulfate. 5 means pentahydrate. We use, we write the hydrate as 1 word. So this is a 3-word formula: magnesium, sulfate, pentahydrate. Pentahydrate is 1 word. Iman had a really good question. The question was, the second part of the molecule, do we take from the data book or data paper? The second part of the molecule, for the record, is always the anion. And yes, you always take this from the data book. Now, let me be clear. It could be a polyatomic ion, or it could just be an element from the periodic table. So you do always use your data booklet, but look at sulfate here. This is polyatomic. Chloride is from your periodic table. So if it's more than 1 element, you would use your polyatomic ion chart. If it's a single element, excuse me, you would use your periodic table. But all of this is in your data booklet. All right, the finale. I'm going to go quick because I have another class here. The finale for you guys, iron 3 phosphate tetrahydrate. Okay, so that means we have iron 3. Iron 3 is Fe3 plus. Phosphate, using my data booklet, is PO4 3 minus. Tetra means 4. Hydrate means water. I'm almost ready for my name. The only thing I need to do is put these ions together, and this is a match, a perfect match. The 3 plus on the iron cancels with the 3 plus on the phosphate, so I get FePO4. I don't need any subscripts, and 4H2O. All right, guys, that is it. This is everything that your new quiz online covers. This is everything that your first test will cover. We will do a review on Thursday. So if you guys on Thursday afternoon have any questions, you can let me know on Thursday. All right, so I'm going to stop my recording now. And if you guys have any questions, you're good, you can ask. Other than that, you are good to go.